Perfect. Right. So question 6. A sequence U1, U2, U3 is defined by UN is 85 minus 5n for n greater than or equal to 1. I just thought there's a great joke coming out my head. Hope you're ready for it. Write down the values of U1, U2 and U3. Don't anticipate the joke. So, U1, what happens if n equals 1? We've got 85, take away 5 times 1, which would be 80. U2, come in. 85, take away 5 times n, so that's 5 times 2. So that would be 75. Now, we've found U2, but we still haven't found what we're looking for.
It's getting worse.
Better than some wine? You reckon? Each other. Thanks. Okay, U3 would be 85 minus 5 times 3, so we end up with 70 after that one. Great, so for 2 marks. Which 2 marks isn't very much for doing that, is it? And considering you had to put up with the joke to get there. Now find the sum of the first 20 terms. Now we've got to get used to the notation here. This sigma sign, remember we've probably started some of the series, don't we? Sigma. That means the sum of. That's all that the letter means. We've used it again in steps, haven't we, since then? And so when it says that, well, actually, that just means we need to add up these terms until we get to the 20th one. Now, you can, if you really want to, go through the whole thing of working out all the 20 terms and adding them all up, and you would get the marks for doing that, but that feels like a slightly daft way to do it. What we want to do is to recognise that this is an arithmetic progression. It has a first term of 80, and the common difference, well, it's going down by 5, isn't it? So it's a common difference of minus 5 each time. And we want the sum of the first 20 terms, because n goes from 1 up to 20. So S20 from the formula sheet is n over 2, 2a plus n minus 1 times d. And we'll write out really, really carefully and deliberately, put in the numbers into the formula, and then work that out. And I watch this, that's 160, take away 95, so 65 times 10 would be 650, wouldn't it? And there we go, for 3 marks was that, to get our value. Good. This is 20 minus 1 would be 19 times the minus 5. So here we've got 160, and we're taking away 19 so close to 95. 160 take away 95, so 65. This is minus 5. 20 minus 1 is plus 19. Minus 5 makes it minus. Alright. Yes. Okay, part 3. Given that U1, U5 and UP are the first, second and third terms of the geometric progression, find the value of P. Okay? Well, let's just try and work out what this says to start with. It says U1, U5 and UP. Well, U1, we know what U1 is, don't we? U1 is 80. U5, well, we've got this formula for it, so let's just double check and say U5 would be 85 minus 25, so that would be 60, wouldn't it? Okay, and we need to find UP, which is the third term, so that's the first, the second, and the third term is UP. Okay. Now remember, UP is 85 minus 5p. And that will be the third term in the sequence. Yeah?
And where's the U5 come from?
The question said that U1, U5 and UP are the first, second and third terms in our GP. Now, if they're in the GP, it's the first, second and third terms, that means the number that you multiply that one by to get that is the same as the number you multiply 60 by to get that. And another way of saying that is that if we divide these, 60 divided by 80, so the second one divided by the first one, that gives us the common ratio. That must be the same as 85 minus 5p divided by 60. Does that make sense? Basically what we're doing here is we're saying that if we take, that's A, that's AR, and that's AR squared. And if we do AR divided by A, that's the same as doing AR squared divided by AR. Because basically all that says is that R equals R. Can you see? Ah. Well, we were told that UN is 85 minus 5n. So if that belongs to that sequence, then replace n with p, and it must be that. So that took a little bit of doing, didn't it? But it gave us an equation that we can solve to try and find out what p is. If we rearrange what we've got here, we've got. Am I doing this in my head? Yes. We've got. I'm not. 360 over 8, which would be 45. Oh, so. We've got that. That's doing 60 divided by 80 times 60. And then rearranging this, we get 5p is 14. If you do 60 over 80, then that's 3/4. That's an easy way of doing it. Who asked? 60 over 80 is 3/4. Times by the 60 is 45. Okay, so we ended up with p as being 8. And then, finally, it said, find the sum to infinity of this geometric progression. Well, the sum to infinity is A over 1 minus r from your formula booklet. But in order to do that, we need to know what r is, don't we? And we've never actually said that in here, except it's there. That's r, 60 over 80, which is 3/4. The first term of this geometric progression was 80. So the sum to infinity is 80 over 1 minus 3/4, which would be 3/20. There we go. Right. Is that all right with everybody? Any questions about that? Okay. Stop the video.